Hello, it's Dumplet here. Here's an item on trigonometry. Given a square ABCD, BD here is equal to DE, and we also have the given that BD is parallel to CE. Find the measure of angle alpha in degrees. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, I guess we can have some primary observations here, and it's that we have parallel lines, so we can try to get some angles here. And in fact, before we do that, we're going to draw one auxiliary line, and that is the altitude from the perpendicular from D to segment CE. Now, why do we want to do this? Since we want to get the angle, we can try to relate the sides into the angles via trigonometry. So the side length of the square is not given, so without loss of generality, let's assume it to be 1. Now we can use our ratios in right triangles. Now notice that this right triangle here, it has measures of 45, 45, and 90. So degree measures of 45, 45, and 90. And we note that the ratio of the sides in a 45, 45, 90 triangle is of the form 1 is to square root of 2. Where square root of 2 is, it corresponds to the side that is opposite to the right angle. So in this, in triangle BDC here, so DC here must also equal to 1, and then BD should have the length of square root 2, either via the Pythagorean theorem or using the ratios. Now, we can notice something here. Since we have BD parallel to CE, DCE over here should also have 45 degrees. Because angle BDC and angle DCE are alternate interior angles. Now, if this is 45 and we have a right angle here, then this must also be 45. So we can again apply the ratio 1 is to square root of 2 ratio on in this triangle. So let's just call this point F for now. So in triangle DFC, the side should be of the ratio 1 is to square root of 2. Now, square root of 2 here is corresponds to DC, since DC is the hypotenuse of right triangle DFC. So we know that the two other angles here should be 1 divided by square root of 2. So DF should be 1 divided by square root of 2, and same for FC, but we're not going to need it anyways. Now next, we have BD here to be square root of 2, so we didn't implement it into this part yet. So DE should also have length square root of 2. And now take a look at the given. We have we have the angle alpha over here, and we have the side length opposite to it in triangle DFE. So in triangle DFE, DF is opposite of angle alpha, and DE is the hypotenuse. So we can use the sine function, because SOHCAHTOA, sine is equal to opposite over hypotenuse. So we can have sine of alpha, that's going to be equal to 1 over square root of 2, 1 over square root of 2, divided by square root of 2. And we can simplify this into 1/2. So sine alpha is equal to 1/2. We have a special angle for that. So sine alpha equals 1/2. It's a special angle. Alpha here must equal 30 degrees. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.